Command's registration page. And with that, I'd like to hand the webcast over to John.
All right, thank you, Carol. So welcome everyone, thank you for joining. I'm sure some of you have had rather hectic days today, so I appreciate that you're here with me. I have an awesome, just absolute freight train of slides to get through here. So I'm going to jump right into it after a quick intro. If you're not familiar with me, my name is John Hubbard. I'm one of the certified instructors here at SANS. I teach a lot of the Blue Team curriculum, 511, 555, and I also just authored one of the brand new courses, SEC 450, which is Blue Team Fundamentals. I co-authored SEC 455 with Justin Henderson, and I am about to release, which I'm announcing for the first time here, a brand new SOC management course today that goes along with SEC 450. I don't have a name or specific details on that, but I can tell you that the beta will be run tentatively around July or August timeframe. So if you're interested in SOC management, stay tuned for that. Another really exciting announcement real quick too, we're starting a Blue Team podcast. And so I'm going to be hosting this podcast and trying to bring on some of the best minds in Blue Team and cyber defense and have them teach you something in a very dense, very worth your time 30-minute podcast episode. And we're going to be trying to do 10 episodes of that for a first season and releasing that in the coming months here. So I whipped up a quick interest sign up page there. If you want to know about that when it gets released, just go over to sec450.com/podcast and throw me your email and I'll let you know when it comes out. One other quick thing, for the first time ever, I know I've had a lot of students ask me about this in the past and when it's showing up, we now have a SEC 450 coin, and yes, it is an awesome Triforce triangle. So I wanted to show this for the first time here. This is the new challenge coin for SEC 450. So there you go, everyone. It does exist and it will be sent to me in the next couple weeks. All right, so jumping right in, why this talk? We've now taught SEC 450 probably 10 or so times. And one of the things I see every single time we teach it is students say, hey, these labs are awesome. I know we're using free tools, but I didn't even realize this stuff exists. And I actually like it a lot more than what we are paying maybe a lot of money for back at my SOC. And I said, oh, well, that's really interesting. I guess, you know, my job here should be not only to teach this stuff, but also, you know, help get the word out that these outstanding tools exist. And so this webcast is going to be just an absolute tool dump full of suggestions for different pieces of a SOC and the tools and functions that it can help bolster and not add any money to your budget. So without any further ado, here we go. Looking at what we're going to discuss here, there are a few different stages of a SOC, and we're going to address tools for all of them today, except for incident response, because I couldn't fit it in. I got 50 slides to go through already, and I'm only touching the first 4 stages here. So a SOC needs to collect data, right? That's a primary concern. If you can't collect it, you can't see anything. From the stuff that you collect, you have to be able to detect things that are potentially bad. And then from there, it goes to triage, where you look at the big pile of what might be bad, try to pick out the worst stuff, and then decide if it needs to have further investigation, if it's a true positive, if it's a false positive. And then once it's confirmed, obviously you toss it over to incident response. Now, as you go through this process, I wanted to make kind of a diagram here of how this all works in the SOC, because I think it's a good kind of mental model for what's happening here. And I'm going to lay out all of the tools that I talk about today against this kind of a chart. And so if you think about a SOC as that box in the middle here, here are all the functions that I just listed. The input to the SOC is all of the events that you collect. And by events, I mean everything that's observable in your environment. You take signatures of what bad stuff looks like. And when you combine those two things, you have detections of potential bad stuff. That is fed by threat intelligence. And when we detect stuff that's potentially bad, we move on to triage and investigation of those events, which then once we qualify them goes to incident response. And then incident response hopefully is outputting remediated issues and metrics on what happens. And we have supporting functions in the SOC like forensics and pen testers and red teamers and all sorts of stuff that helps the SOC do this better. And so this is the kind of model we're going to line up these tools against. Now, what I wanted to say here in terms of data collection, because that's one of the first things we're going to talk about, is think about all of the data that you could collect, right? Pretend this is a Venn diagram. PowerPoint doesn't have a perfect Venn diagram chart, so I went with the targets kind of circles, concentric circles here. On the outside, we have all activity, whether you see it or not. There is some subset of all of the activity that's happening in your network that you collect, and that's what we're calling events for this presentation. So every observable thing, that is your collection piece. Then you have the what might be bad, which are alerts for this presentation, and that is the detection piece. And then of all the things that are alerted on, you have to go and triage those and decide if they're actually bad or not and qualify them. And if they are, we're calling them incidents. And that's your investigation stage. You're investigating incidents, saying, yes, this is something that needs to have incident response involved. Now, the key thing to understand here is if you don't do the early stages correct, the later stages just cannot function, right? You can't investigate something you never knew happened in the first place, so we have to get collection right. Otherwise, it's just never going to happen for us. Now, looking at this more as a security architecture diagram, on the left here, we've got a very, very basic kind of network, right? We have devices down here on the bottom on the left, and we have them going to a switch going to router, router, firewall, and firewall to the internet. At some point in your network, you have these endpoint devices that need to be recording what is occurring on them. So typically we have some kind of host agent or other way of recording what's going on there. And that information is being collected and sent over as host activity logs and alerts. So we're collecting events, we're collecting alerts, and all of those things are going to a SIM. Outside of that, we have the other type of data, the stuff that we collect from the network, right? So whether this is a network tap or a mirror port, it doesn't really matter. We're just saying we're taking stuff that's actually traveling over the wires and we're feeding that into some kind of security appliance. Some of those security appliances will be recording PCAP of what's going on. Other ones will just be recording the metadata and net flow and stuff like that. Ultimately, we take this information and we use that as well. And the stuff that is metadata and net flow and things that can be converted into text will be done, or we'll have that done to them, and then that text will be sent over to the SIM. Once the SIM has this information, it now has a pretty comprehensive view of what's going on, right? We've got network and activity logs, host activity logs, and then we match that with our threat intelligence platform here. And this is where we take the signatures plus all the stuff we see that's happening, output alerts, send that to a triage queue, whether it's in the SIM or not, and then things become an incident and go to our incident management system. So as I go through this presentation, keep this in mind as well as the other models I've shown you, and we're going to fill in where all of the tools I'm about to start talking about here fit into this, right? So it's collection, it's detection, it's triage and investigation. We're picking up events, we're picking up alerts. We're going to be doing analytics. We're going to be doing triage and investigation with threat intelligence and an incident management system. And to make this all work better, as I had on this previous slide, I didn't point out the automation and SOAR frameworks up here, which are generally applicable to this piece, right? We're collecting stuff that may or may not be good or bad, and we have automated actions and SOAR, which is security, orchestration, automation, and response tools that help us maybe do this triage more efficiently or enrich data and give us these answers more quickly. So we're going to hit tools for that as well. All right, so with that, let's jump into the tools themselves. First of all, network, event, and alert and data collection. I broke this up into 3 different pieces here, and some of these will have a little bit of overlap, but in general sense, we have stuff that is event focused, and one of those items is Zeek. We'll be touching on that. Intrusion detection, we have Sorocaba and Snort. Everyone's probably familiar with Snort, but you may be less familiar with Sorocaba, so I'm going to discuss that one. And then Moloch for full packet capture. Most companies are probably going to have an IDS, but where they start to fall off, I often see, is in the full packet capture or just capturing all network events area. So those ones are probably the most 2 important things here, and we're going to talk about those in more detail. So the first thing is Zeek. You may have formerly known this as Bro. This is a pretty common one. We talk about it in a lot of SANS classes, but it absolutely has to be in here because this is one of the most important tools that you can probably have for threat hunting on your network. It takes all of the traffic that is being sent to it, whether it's from a network tap or otherwise, and it acts like a prism. And I say that in the way that it takes the traffic and it splits it into different text files that describe the things that it sees. And so, for example, NetFlow, there is a NetFlow equivalent type record written into the con log. So it says who is talking to who, the IP addresses, the source and destination ports, protocols, and all of that. And then we have a log for DNS. Every DNS lookup, where did it come from? What was the domain name? What type was it? What was the response? And the same thing for HTTP requests and a whole bunch more stuff. When you are doing threat hunting, you need to look for anomalies in a lot of cases, and this is one of the best single sources for that data. Your IDS is going to be capable of picking up stuff that is known bad or maybe known anomalies, but when you are starting looking for data for threats that you're assuming are in the environment, but you may not know exactly how they're operating, you kind of just need to have a record of everything that happens. And so if you don't have that information, Zeek is definitely the solution for you. It just needs a copy of traffic. You cut these things into logs. Those logs get sent to your SIM, and then you can do a bunch of awesome data manipulation and visualization and analytics and whatever you normally do. So absolute must-have here, which is why this one is first. Great for threat hunters. Speaking of intrusion detection, Sorocaba is another one. Sorocaba, very similar to Snort, and if you're familiar with Snort, you can kind of get the idea, right? It takes traffic in and it highlights stuff, hey, this might be bad. It looks like an exploit kit, it looks like a virus being downloaded. It could be any of those things. However, Sorocaba I like a little bit more. I think it's easier to work with, it's multi-core, and it does a little bit more pleasant data style output. It's got a nice JSON output, and that JSON output not only includes alerts, but it also will give you Zeek-like information for every single event that's going on. Now, is it as good as Zeek? Maybe not quite, but it's very, very close. And so if you want one tool to get you both alerts and events for your network, Sorocaba is great at doing that. And it's all in JSON format, which can easily be sent. It's all cut into a single file called eve.log, which you can forward on to a SIM. On top of that, it will also do PCAP. And so this is kind of like the Swiss Army knife of network security monitoring. Really, really powerful tool here. If you haven't looked at it, I highly recommend you check this one out. Great, great tool. Then, full packet capture. A lot of companies don't have this, and that's understandable because it can be expensive, especially if you're getting a commercial tool. But the good news is you do not need commercial tools anymore to have really, really awesome full packet capture. Please check out Moloch. It's one of my favorite open source tools out there for full packet capture. Great, great solution. There is a live demo you can play with here at http://molo.ch. You can log in and play with the interface and all of that. It does not include the data for the full PCAP in the online demo, but all of the metadata and information is there. What this does, it takes a copy of network traffic, it records it all. It also records events in JSON format if you want to export those. But the cool thing about Moloch is it's meant to run constantly all the time. You may be used to looking at PCAPs in Wireshark. Moloch takes all of the PCAPs and makes them into a thing that you can constantly look at and just leave running and then go through and search in their web interface and see all of the detail here. And it's a little bit difficult to see in this. Maybe I can blow it up a little, but you can see all the GET requests, you can see the host names and everything. And there's a lot of different views that you can generate here. Really, really great tool for parsing out key items from your PCAPs. It has the ability to pivot to various tools like CyberChef and other things like that built in. Render the data. If it's a picture and you don't want to see the bytes and you want to see the actual picture, you can do things like that. You can do XOR and unXOR on data bytes, export files from it. Great, great tool. Highly encourage you to check this one out if you don't have a full PCAP solution. Oh, and it stores everything in Elasticsearch as well. So it's very easy to, very fast to pull up all that information. And so for network security monitoring, these are the tools here that we're focused on, right? They fit in where they get a copy of network traffic and they're recording PCAP, they're sending network activity logs, they're sending alerts. So some things are sending everything that's happening, which is Zeek, and some things are focused on sending actual potential bad things, which is Sorocaba and Snort, although they all kind of do similar things. And so it depends which one you want to go with, but they're all great solutions. Now you may be thinking, okay, now I have to set up 3 different tools. No, you're probably familiar with some of these tools as well. There are NSM distributions out there that actually make setting up Zeek or Sorocaba or Snort or anything else very, very easy. These are some of the ones that are out there, and I won't claim to be an expert in all of these, but I wanted to bring awareness to them. I'm gonna step through a few of these here. Security Onion, you're probably familiar with. This is probably my favorite one of the NSM distributions. It's the most popular one, I would say, by far. Most people, if they're doing all open source NSM style collections, Security Onion is going to be their go-to. It is a simple kind of install where you just next. Here's my listening interface. Here's where I'm going to manage it from. And you have set up immediately IDS with Snort or Sorocaba. You get events from Zeek and Bro. You get full PCAP done, not with Moloch, but just recorded on the back end. And then you can summon all of that information through the files that it records. And then you have a NIDS console with Squeal, and Squirt is another one they have that's web-based. And then there's asset data that it will cut out from Zeek and from Prads. And you have a SIM to show you all of this data built from the Elastic Stack, which is something we'll also talk about in more specific later. But you'll see Elastic show up in a lot of these solutions here. And so really, really great tool set here. You're probably familiar with this one. Some of the other ones that are out there that have a excuse me, similar architecture to Elasticsearch, but slightly different. I wanted to call attention to those as well, because depending on your recommendations and requirements, you may need something slightly different, something that can handle data in different formats and otherwise. So one of the other options out there is Rock NSM. It does do full packet capture with Google Stenographer. It has Zeek, it has Sorocaba. It does recursive file scanning, which is really, really important. Think about all the files that you get going through your network, right? Someone may be downloading a zip file, and yeah, the zip file of that, if you take the hash and you throw it in the virus total, it may not be known bad. But inside that zip file might be, let's say, a Word document, and inside the Word document might be an executable that's an embedded object. If all you're doing is scanning the zip file, you won't know that 2 layers deeper, it's actually a virus, right? And so FSF is a framework that's included in Rock NSM that can do that sort of stuff. There is message queuing and distribution with Apache Kafka, which makes sure that there are no messages dropped and acts as a message broker. And then ultimately, it's forwarding all this information to the Elastic Stack through Logstash, and you use Kibana to interface through it. So that's another option as well. One I don't hear as much about, but has a similar configuration, is Selks from Stamus Networks. The way they describe it, complete Sorocaba IDS and IPS ecosystem with its own graphic rule manager. And so they use Sorocaba for IDS, and the graphic rule manager that they have here is the Serious Community Edition. You can download this and run it outside of Selks. It is a way to graphically manage a rule set for Sorocaba. So I wanted to throw that in there. The rest of this stack is pretty similar to what we saw previously, so I won't talk too much about that. Evebox is one that will pop up later on in this presentation. Helk. Now this one is where we start getting very, very serious. This was created by Roberto Rodriguez, really interesting project focused around data science. And so the way he describes it on the GitHub page is one of the first open source hunt platforms with advanced analytics capabilities. And boy, does it have a lot of that. We can see the SQL declarative language, there's graphing, structured streaming, and all of this stuff all wrapped in here. We've got Hadoop, we've got KSQL, we've got ElastAlert, Graph Frames, Jupyter, Apache Spark. This is when it starts to get real, real serious. If you want to get into data science and looking at your data in ways that may be on the cutting edge of Blue Team, this is a great kind of package put together to help you get all this going. As you'll notice, a lot of this is still the same kind of underlying framework. We have Beats agents, which we'll talk about later. We have Kafka as a message queue, and we have the Elastic Stack, ultimately storing the data, with ElastAlert as a rule engine, and Sigma, which we'll also talk about later, as a way of standardizing the analytics that are going to be used here. Jupyter to save analysis types, which we'll also hit later, and then some of these other graph frames and Apache Spark to really tear apart the data and do statistical analysis on it and things like that. Cape Stack. This is one I also don't hear too much about, but I think it's a really unique project, and I wanted to make sure it was put in here because it has a bunch of unique tools for operations for a SOC. It's operationally focused, as they describe it. It's a service hub for putting all of these tools up that a SOC needs to communicate and operate day to day. So it's less focused on the Elastic Stack, although it does still have some of that down here. I wanted to throw out these because there are other things that a SOC has to do day to day, right? And we may not want to pay for those tools as well. A lot of us communicate with things like Slack, especially in situations like right now, right? But what if you have some kind of restriction where you can't share that kind of data and talk, in a cloud-based chat platform? Rocket Chat is a Slack alternative that can be self-hosted. We have Etherpad, which is, I guess, kind of like a OneNote replacement where everyone can be looking at a document and everyone can be editing it at the same time. We, of course, have version control documentation stuff. The Hive, which we'll touch on later, diagramming with Draw.io, data analysis, VoIP solutions with Mumble built in, and then even some container management tools. So Portainer, if you ever get into Docker containers and running all of this stuff in a containerized way, Portainer is actually a great tool for seeing all of your Docker containers running. It makes a web interface for looking at the Docker engine, and then it allows you to start and stop and see the logs for all of your running containers, which is really cool. And so I thought this was a unique kind of set of tools all put together in one that I wanted to highlight as well. And so those are NSM tools and NSM distributions. But one of these other pieces of data that we need to have is our open source data collection for hosts. And so I tried to break this down into two kind of vaguely similar sets of tools here, right? We have supplemental event generation. So this is going to be things that can go on a host and record things that maybe that operating system doesn't have the option to record right out of the box. And so this is going to be stuff like OSQuery and OSEC and SISMon and things like that. And then we have the tools that help us move that data off of that endpoint and send it to a SIM in a more solid way, I guess would be the way to put it. Over here on the right side, I'm not going to cover all of these tools, just Beats and NXLog, because so many of these open source tools rely on the Elastic Stack. And NXLog is my second favorite one here, very flexible log agent. FluentD and NiFi, I'm not going to have time to go through, but if you want to Google those up, some other really interesting solutions for logging, log management and collection. OSQuery. If you haven't seen OSQuery, I highly recommend you check this one out. This is a project that started at Facebook, I believe, and what it does, imagine all of your hosts are running this agent for OSQuery, and it's writing all of the details that would be, well, maybe not all, but most of the security relevant events into a database. And so this is what connections are being made, what processes are being run. As you can see in the screenshot here on the slide, PowerShell scripts and things like that. I took that from a malware analysis blog post on Medium there from HackerNoon. That is an example of the power of OSQuery. All of this data is being recorded on each endpoint into a database, into different tables, sorted by the type of data that it's holding. Then, once that data is being recorded, you can centrally query it all. You can schedule and say once an hour, pull information. You can set out kind of on-demand things to be run and pull the information back. Think of it kind of like EDR. It will go out and record a bunch of information that's going to be relevant to you when you're trying to detect an attack. And so you can bring all that information back, see it from one centralized location, which is generally something that's fairly expensive to do with an EDR solution, but here you go, free option, compatible with Linux, Windows, Mac OS, FreeBSD, really cool stuff there. A different take on this. I believe you say this Wazza. I'm not exactly sure, so we're just going to go with that. It's a open source enterprise-ready security monitoring solution, and as it says, for threat detection and integrity monitoring and more. This is an agent, kind of like OSQuery. It sits on your endpoints, and it can watch for a number of things that are going to be relevant to security to occur. It can look for file changes that you wouldn't expect. It can detect vulnerabilities. It can find changes in configuration that are relevant. It can help you do incident response by taking action for you. There's certain response actions. Basically, it's a host intrusion detection system that has a little bit more information that it will record, and also takes that information, records it in a nice format, and then forward again that onto an Elastic Stack. And then it has dashboards and other stuff set up for you to make it very easy to view all this stuff and manage your agents and so on and so forth. So if you don't have a host intrusion detection system, Wazza is one of the options for you. OSEC is the other option. They call it the world's most widely used host-based intrusion detection system. A bunch of similar things here. We have intrusion detection based on the content of logs. You can set up rules, tell it what to look for. You can do compliance auditing. You can do inventory. All of this will be spit out into JSON logs, which I keep saying because it's my favorite log format. It makes parsing things very, very easy in your SIM. Why is that so important? Because you can't do analytics on something that isn't parsed correctly. And so a lot of the thing I like about these tools is they will make JSON formatted logs that you really don't have to worry about the format for. You just kind of forward them on and say, this is JSON, and everything sort of works, even if fields change and names change and things like that. What we've been talking about so far has been at least born of Linux. OSEC and OSQuery and all of that were originally kind of Linux-only tools. And so I wanted to throw in the Windows option here for additional logging for things that you might not have. Again, if you don't have EDR, your next best option is probably to go to SISMon. SISMon, if you haven't heard of it, is a free tool from Windows sysinternals or Microsoft sysinternals. You install it, it's a driver, it's a service that runs in the background, and then you can give it a very detailed XML setup that will allow you to, say, record all of the DNS queries that are occurring, record all network connections, record all the processes that are running and all of the command lines from them, check if these things are signed, look for file and registry modification, look for WMI events. This is probably the single best thing you can do for visual or for detecting and collecting of relevant information from your Windows endpoints. Bringing this back and then visualizing this data is going to give you incredible power to detect anomalies in your Windows machines. And so I would highly, highly recommend this one. The key to success with SISMon is a rational filtering policy. You do not want to collect every single thing. And so, you have to come up with, well, we want to collect things but that are running and new processes that are being created, but maybe not if they're signed by Microsoft, or maybe not if they're running out of these certain folders. It can be easy to flood yourself with data if you just say SISMon record everything. The standard setup for this one is the Swift on Security setup here. If you go to GitHub and you search Swift on Security SISMon setup, great set of starting filters to apply here. Additional logging. I hear a lot about containers, and so I wanted to include this. Sysdig has some tools called Inspect and Sysdig Falco that will allow you to watch what is occurring inside of a container. And so down here, I'm showing that someone is, if you're not familiar with Docker, basically entering into a Docker container and running bash, and then in bash, they type ls, and then they type copy the shadow file into an HTML folder, which is someone potentially trying to steal password hashes, right? Up here, this is what Falco is recording. It's saying a shell was spawned, sensitive file opened or reading by non-trusted program. And so it's recording stuff that's happening inside a container. This is really important because containers are very ephemeral. The whole idea is to bring them up and then throw them away when you don't need them anymore. The problem being, when you throw them away, you will have no idea forensically what happened because that information is gone. And so you need a way to log what's going on. That's one of the options out there for you. Other things you can do for Linux activity monitoring. Audit D is built into nearly all distributions of Linux. So you can turn on Audit D, get incredibly detailed logs. You might not want that, so some of the other options that you can check out, Go Audit, Snoopy Logger, and Audit Beat if you're using an Elastic Stack-based collection method. Other things, NXLog. If you don't have a log agent that you like, NXLog is a solution for you. This will collect nearly any format of log that you want from an endpoint. It could be a database, it could be Windows events, it could be text files, and it could be a whole bunch of other stuff. There is a multiple input, multiple output kind of configuration that you can set up with NXLog, which is a very efficient log agent written in C, and it has a community edition, which is free and open source. It's probably the single best free log agent in terms of features and capabilities out there. So we're a big fan of this one as well. If you are using Elastic Stack, as we've kind of referenced throughout this, it's a big common factor in a lot of these free and open source tools. So Beats is the name of the group of agents that you can deploy. Now, Beats are done a little bit differently than some of the other types of things that we talked about here for log collection. With Beats, every type of file you want to pick up gets its own beat. And so if you have a Windows machine where you want to pick up raw text files and Windows events, you would actually need to install both FileBeat and WinLogBeat, which is fine. They're both very lightweight, but that's just the paradigm that it works with. It can feel a little weird because some people are like, oh, agent fatigue, right? We don't want to install two agents, we just want one. Well, okay, fine. The overhead of running two in this case is probably the same as one bigger agent, but it's a little bit different and run as two different services. So that's how these work. They exist for multiple different types of data. AuditBeat for auditing what's happening on a Linux system. PacketBeat if you want to do network data capture done on the host. I've had some students ask me, hey, John, I need to capture network events, but I can't get access to the actual networking infrastructure because it's in the cloud or otherwise. What do I do? My answer to that, PacketBeat can actually tell you what's going on. Now, it's not going to be doing full PCAP, but it will give you Zeek-style readouts of what type of protocols are being used and who's talking to what. And it's a host agent that records it all and sends it to the Elastic Stack and records it and makes it easy. So there's that. Journal Beat for the Linux journal, Function Beat if you're doing serverless things, Heartbeat for operations and uptime and all that kind of stuff, plus a whole bunch of other community beats. The beats standard is a way of transporting data, and you can make a beat for any type of file input you want. So there's a whole bunch of DIY kind of community beats out there as well for specific applications. So that takes us to a picture now that we have covered both how do we capture and also do some detection on the network traffic that we're recording and sending over to here, and then also from our host. So how are we going to comprehensively see everything that's happening on our endpoints and everything that's happening on our network? We have a whole bunch of open source solutions just for those two pieces. We're going to continue on and fill out some of these other boxes here now as well. Next set of stuff. This is our data analytics, triage, and investigation set. Broke this up into threat intelligence platforms where MISP is going to be the one that we talk about here. That one's definitely by far my favorite. Analytics and analysis kind of frameworks, Sigma and Jupyter, we're going to touch on those. Alert triage, we have Evebox and squeal as some options there. And then SIM and log management. We've seen Elastic Stack come up a number of times. I don't have time to go over these other options, but other things that I see often used that are also free. Graylog is out there quite a bit, Alien Vault, OSIM. And then there's the Mozilla Enterprise Defense Platform, so MozDef as it's called sometimes. And then Apache Metron, which I don't often see out there, but is an interesting project to combine a whole bunch of big data tools together and then give you a really comprehensive view that enables some data science and other analytics. So those things are out there. We're going to focus mostly on Elastic Stack because, as you saw, many of the tools already are using it as a backend. So it's becoming probably the biggest player in the open source data collection and analytics space. And then when it comes to incident management, if you don't have a tool to do ticketing and kind of triage, the Hive is definitely my favorite in this as well. So we're going to talk through these. First, MISP. Every time I teach 450, we do labs with MISP, and I always ask, how many people out there are using MISP? And I usually get a couple hands, but not a whole bunch. And I'm not sure exactly why that is. I know there's a lot of other threat intel platforms out there, but I usually follow that question up with, okay, what else are you using? And then a lot of people don't say much, which tells me either they don't want to tell me what it is because they can't or whatever, or they don't have any dedicated threat intelligence platform. Well, you do want that. You need some place to store all of your indicators and details on past events and any information you've got and gathered on threat actors. And so MISP is a great solution for doing that. I actually have a few slides here following this just to show you what it looks like. MISP is for collecting tactical level threat detection. So we're going to be recording attributes about events, as they are called. So an event could be a single like APT style attack, and the attributes could be domain names that were used, information about the tools and the malware, and tagging it and correlating it across time through other attacks that same actor has perpetuated against you. And so MISP is great, one, because it allows us to do all of this for free, but also really nice web UI and built for sharing. So if you want to, anything you put into MISP, you can connect to other people who are running MISP. And then once you see that indicator, it can be automatically shared and pushed out to them. Stuff that they see can be pushed back to you. So if everyone started using one of these as a standard, it would be really nice because once one person saw a specific command and control server, everyone would know about it. So here's what MISP looks like. We have an events list. This is just some sample events here. We've got various tools that are tagged in here, information about the events, right? The Orcus Rat and Fancy Bear and Bad Rabbit and all sorts of stuff. Each one of these events is a container for a bunch of attributes about that specific attack. And so this is kind of the higher level structure. Each one of these things can be streamed in from an org that owns it, or it can be created by your own org and pushed it out. You can tag it with various things, and there's a whole world of tags you can apply or not apply, and put it in clusters as well by tool and by threat actor, ransomware, whatever it is you want. Very, very flexible platform. How do we add events? When you make a new event, you can just use the free text import tool. Basically, you just paste whatever you want in here in bulk text. You hit submit, it detects what type of data it is, and it says, yep, okay, so I've seen these hashes before, and here are the events I've seen them in. Here's the type of category they are, SHA-256, this one's a URL, and you can categorize each of these things. And right from the first moment you put that information in, it's telling you, hey, I've seen this before. And the whole idea behind having this threat intelligence platform is starting to build up a profile of your attackers and not just dealing with information or incidents on kind of a one-off basis. This helps you see the relations of things across time. So in this case, let's say we had these two hashes and they were seen in event 149, 184, 244, and 703. Well, if all of these things were attacks that happened to your organization over the past couple months, you probably wouldn't visually understand that this hash has been seen before, but MISP very easily says, oh, I've seen that before, here's all the other events. And that helps you say, wait a minute, this same backdoor keeps coming to us. Maybe this is the same attacker behind this. We can start to figure out who they are, what they want, and then maybe improve our defense based on that information. And so MISP, definitely my favorite piece of software for threat intelligence. Highly recommend you check that one out as well. Finally, a specific discussion of the Elastic Stack. So this has been the heart of data storage for many of these solutions. I'm not going to go too far into it other than saying this is the architecture that it uses. We have logs, we have beats agents, doesn't really matter. Any kind of format that you can use to get text logs to Logstash. Logstash then takes those as a log aggregator. It will convert all of the logs from whatever format they're in into a JSON document. And then that JSON document is sent to Elasticsearch. Elasticsearch is the heart of this whole stack. It's really just a search engine, and it's a search engine that you have to send JSON formatted data to, and you will receive JSON formatted data back from, and it acts as a web server. So basically logs come in, they can get converted into JSON with all the fields split up for everything you wanted to parse out. They get stored in Elasticsearch using HTTP over port 9200. And then you go to Kibana, and Kibana is searching all of those JSON documents and pulling them back out of Elasticsearch, and then allowing you to visualize them and see them in a much more kind of functional and easy way with Kibana itself. And so that's really all that's happening here. We're taking logs in, we're turning them into JSON, storing them here, and it's a whole bunch of database kind of like indexes, they're called, of all of your different types of logs, which you then search through Kibana. If you're interested in the Elastic Stack, Justin Henderson and I created Sec 455, which is a 2-day course on how to set up the Elastic Stack as a SIM, just how to operate it, how to understand all the different paradigms for data storage and all of that. It seems intimidating going into it, but it's actually not that complex. Sigma. This is for analytics. Now, this one is getting more and more traction over the years. I really, really want Sigma or something like it to become a standard because it's so incredibly important for the blue team. This is a huge innovation for us. What Sigma does is it makes it so that you can write a analytic to find something in a generic way and then share it across companies. And so the way that it's described, Sigma is to logs what Snort is to network traffic and Yara is to files. We can use Yara, if you're not familiar with it, to write signatures to find files. We can write Snort signatures to find network traffic, but we haven't been able to generically say, here's how to find stuff in logs. And so Sigma does that for us. The dream of Sigma is you can write a generic signature in Sigma format, which is a very easy to understand kind of YAML text-based format, and then pass that out to everyone you know. And everyone can run it through a Sigma converter, which will convert it to whatever product they have. It supports all the big SIMs, Splunk, Elasticsearch, and QRadar, and everything else, right? Plus Windows Defender ATP, PowerShell, grep, and a bunch of other things. And then once it goes through that conversion process, it gets spit out in the right format and syntax, and then you have a specific mapping file that says, and this is what we call these fields, and then what comes out of that is a search query that you can drop right into your SIM. And you didn't have to know anything about how to write the right syntax for your SIM. You didn't even have to know your company's field names because all of that work has been done ahead of time. And so with this, what we can do is have vendors or anyone come up with a Sigma style signature, send that signature out to the whole world, and then all of us feed it through this conversion process and put it directly into our own products with our own field names, and everything still works. This is moving us towards blue team standardization, which is one of the most important things we're going to need if we want to be successful in the future. If one person anywhere in the world could find out a new attack technique, write a Sigma signature for it, and have us all immediately be protected from that, that would be an epic place to be, right? It would make attacking very, very difficult. And so Sigma is moving in that direction. The MISP tool I mentioned earlier is compatible with Sigma signatures, so you can actually save a Sigma signature into MISP and then push it out via MISP to another company that you share with as well. So great stuff here, big fan of that one. Another thing, Jupyter Notebooks. You may have heard about Jupyter Notebooks but not dove into them yet. Yes, they are a bit advanced, but they are another very, very important play towards standardization. Again, standardization is going to help us because one person finding something and distributing it to everyone makes that attack technique much harder to use. And Jupyter helps us capture not the signature itself, but analysis techniques. Think of Jupyter Notebooks as a way of capturing a bunch of Python code and then running it and having visual output that helps you understand whether or not there may be an attack in the data or other various data science kind of type analysis. What you do with Jupyter, anyone on earth can write a Jupyter notebook and say, it's going to take in, I don't know, DNS logs, right? And then what they do is they encode all of the commands in Python or really any language, it doesn't matter, but Python's the most common. And it says, run this command on it, visualize what comes out, do these kind of transforms to clean up the data, analyze it for randomness, do whatever, right? And so what we're doing is we're saying, okay, capture this notebook, pass the notebook out to everyone, and now someone who wrote a Jupyter notebook on data science can share that with the world. And whether you know anything about data science or not, now all you have to do is get the data that they say you need, DNS logs or whatever the input for that notebook happens to be, get the notebook, combine the two, hit play, have it just run through, and you get the output of someone else's very, very complex analysis without having to know anything about data science or even how the code works, right? And so this is a really interesting way of capturing and standardizing analysis techniques that I think is going to be a big player in the future as well. The Hive, one of the biggest ones in this presentation, I would say. If you don't have an incident management system, a ticketing system where you're saying, hey, this is an actual incident, we have a problem here, I need to analyze it, the Hive is a great, great answer for you. Every time I teach, again, Sec 450, I also pause at this moment and I say, how many people here love their incident management system? And I pretty typically don't get any hands. Now, the reason for that, it's kind of like a SIM, right? SIMs and incident management systems are the two tools that no one is 100% happy with, but there are some that people are more happy with than others. It kind of depends on what exactly you're trying to do with it and otherwise. If you do not have a ticketing system you like, the Hive is a great place to go. It lets you do alert triage, it lets you do case management, and each case can have playbooks, which they call case templates, and you can say, every time we create a phishing incident, for example, these are the steps that an analyst has to go through before this case can be closed. As you go through each of those steps, which are called tasks, you can put a work log associated with them. You can put observables into it, and so you could say, the phishing link is Microsoft Office, 3365.com or whatever it happened to be. Put that information into the Hive, store it all there, and then the Hive integrates with both MISP and Cortex. And so Cortex is something I'll talk about in a moment, but basically once you put an observable, any kind of IOC in the Hive from what the incident you're working, you can immediately turn around and in an automated way go do lookups on virus total or do DNS lookups or take actions based on any other kind of threat intel API you have access to. It lets you do a bunch of really awesome things without ever leaving the ticketing system, which most ticketing systems do not have built in, and this is free. This is where a lot of students are like, whoa, this is way better than what I have, and this one's free. That's crazy. And so if you don't like your ticketing system, check this one out. They have a virtual machine you can download and you can play with the Hive. You can use Docker to bring it up and test it out really easily. Great solution. Here's what it looks like in the alerts tab. You have a whole bunch of alerts that came in. You can triage these and you can escalate them to cases, and you can apply a case template to those cases if it's something you actually need to deal with. So someone looks like they downloaded an executable, right? You would click on this, you would see all the details, and then you would say, yep, I'm concerned about this, turn it into a case, apply the case template for potentially malicious executable downloaded. All of the IOCs are already in there. They're called attributes in this case. It's going to say domain names and everything else that was parsed that was sent to it. The Hive has an API, so any of your tools that can send over data in JSON format with an HTTP REST API can create an alert in the Hive. And so everything can go here, and you can take this information, turn it into a case. The observables are ready to go. You can use Cortex to enrich the observables, which I'll talk about in a moment. And then it makes all of this investigation stuff as painless as possible. So really awesome tool. They just hit version 4, which is a major release for them. It's not officially out, it's in release candidate 1, but they've completely redone the whole back end of this. It used to be based on Elasticsearch, like so many other things, but they've changed some of the back end technology because they were running into some issues when they wanted to do RBAC and multi-tenancy and other stuff as well. And so look for some awesome things to come as that new version kind of starts to mature as well. So that's a way of doing alert triage inside your incident management system. But a lot of people like to do alert triage directly from their IDS. And so if you want to do that, Evebox is one solution. If you play the new version of Cyber Defense Networks, which is now out, very exciting, cool kind of contest if you ever go to a SANS event or online. Evebox is the tool you will be using. Shows you all of the alerts that have gone off for Sorocaba, lets you see all the PCAP information, and lets you browse events. And so I wanted to throw that one out there. If you're using Sorocaba as an IDS, you should also be using Evebox if you want to do a dedicated triage of those Sorocaba alerts alone. There's a tool for that. And then we have Squeal. If you're familiar with Security Onion, this is the default kind of tool that's been in there for a long time. Squeal is kind of ugly looking, but it's actually really awesome at what it does. Any snort alert you see in this list here, and then you can click on one of these alerts, see immediately the rule that it triggered against, and see the actual packets related to the alert. As an analyst, everything is about efficiency, right? You want all of the data that you might have to look at one click away, and Squeal nails this. You see all of this immediately as soon as you click. You can right-click on the alert ID and pivot directly to the PCAP. You can pivot to Zeek logs. You can see a transcript. And so whether or not you use Squeal or something else, those are the kind of features you want when you're going to triage IDS alerts and anything like that. So another great tool for doing this sort of thing. So that brings us to here. We now have in our network our host data collection and detection kind of tools. We have our network detection and collection tools. That is sending that to one of these many, many different kind of SIM platforms, Elastic, Graylog, OSIM, any of these things. And from there, we can take the data we collect. We can use Jupyter notebooks to capture and standardize analysis techniques. We can use Sigma to apply standard generic analytics that have been downloaded from other organizations with totally different products. And then those alerts can go over to Evebox or Squeal so that we can very easily understand, are they a true positive? Are they a false positive? And then go from there. And then anything that is qualified as an incident can go to the Hive, where we can then start writing our task logs, make our playbooks, do enrichment directly based on Cortex, which is what we're going to get into here once we get into our final piece, which is SOAR and automation. So we've covered a lot of this here. One final section to go. Orchestration and automation. This is a very, very important product category. I'm sure you've all heard of SOAR kind of taking off now as a just huge product area because it takes out the work that analysts hate to do, right? We're not being paid to click and move data around. We're paid to think and understand, is something compromised or not, right? So if we can take out the mechanical work, which is what SOAR tools are doing, everyone's life becomes better. So I've gathered some of these tools here. In terms of SOAR, there is not a great solution for that yet, but I have a couple options for you there. In terms of automation and enrichment, we have Cortex, which goes with the Hive, and I'll show you that. And then I squeezed this one in here. It's kind of a different product, but automation of malware analysis just needed to be mentioned because Kuku Sandbox is so awesome. I also often ask about this one and people don't know about it, so we'll cover that real quickly as well. Cortex. Cortex is meant to be paired with the Hive. So you download the Hive, you get Cortex with it. These two are separate programs, but they run together, and actually both of them, by the way, integrate with MISP. And what you can do is you put in your observables directly into the Hive, and then you can go to Cortex and enable one of hundreds of different analyzers. And those analyzers are things like integrate with VirusTotal, integrate with hybrid analysis, integrate with Joe Sandbox, look up and push things to my firewall, whatever, right? There are tons and tons of analyzers. And the cool thing about this is you never have to leave the ticket that relates to that specific IOC to take these actions. So your workflow might be, hey, someone just got a phishing email. I want to know if anyone's ever seen this before. You're typing up the case, you put in the observable evilsite.com, and then you can say, hey, Cortex, run this through analyzer A, B, C, and D. Hit a button. All of those lookups for all of your threat intel sources are immediately consulted, and the results come back and just show right up to you in the Hive when you just hit a button. That is super efficient workflow. There's no point in you opening up a separate tab and typing that information into 4 different tools when you can just hit a button and use the API for all those tools. Cortex does that for you. And with all of this, there's of course a MISP analyzer. You can push things to MISP. You can query MISP for things and all of that as well. So really, really great tool that goes with the Hive specifically if you're using it for incident response. I put this in here as an automation engine. There is a difference between automation and orchestration, and the best way to describe it is orchestration is putting everything together step by step in a bunch of automated kind of individual steps. And so automation is like the individual thing that's happening, like one step on an assembly line, and orchestration is kind of like the whole assembly line. So an event may occur, trigger an automated action, and then that may say, okay, was this the outcome or was that the outcome? If so, do this thing, do that thing, and then continue on and so on and so on. The individual step is automation. Cortex does that individual step of looking stuff up, but it is not an orchestration tool. It will not fully run through a playbook for you or anything like that. It's just kind of an automated enrichment engine. More towards orchestration, there's something called IBM NodeRed. And so it's flow-based programming and it's automation geared towards IoT. But that being said, it does all of the same functions that a SOAR tool would use. It just doesn't have specific functions for security tools. And so what I mean by that, when you're trying to automate and orchestrate a whole playbook to occur, what are you really doing? You're taking in information, maybe a file hash, you're making some decision on when I look this up, is it good, is it bad? Take this other action, that other action requires a REST API call, we're gonna write a file, we're gonna send an email. IBM NodeRed does all of this stuff. 2 of the labs in Sec 450, we use IBM NodeRed to make something that will automatically push a domain name into a DNS RPZ to block it for an entire company. And we also make a different flow that will automatically take a file that has been dropped into a folder, hash it, send it to an API, and then if it comes back as being a known virus, email the SOC. And both of those things we do in about 20 minutes each. And so NodeRed, although it's not security focused, is basically the same thing as SOAR. It's a bunch of blocks for atomic actions that are going to be taken. You put them on a background, as you can see here, you connect them and you say, make these decisions based on this input and that output. And that's really all that SOAR is. It's just SOAR also includes a bunch of specific tool integrations where NodeRed is going to say, I'll make an HTTP call. What do you want it to look like? And so very similar, but different in that it doesn't have specific integrations, but totally free, easy to set up with a single line with Docker. If you go to their installation instructions, throw in the Docker command, you can play with this very, very quickly. The only tool that I saw that was actually free and SOAR is called WalkOff. It's by the NSA. I can't say too much about it yet because when I tried it originally a few months ago, it was a little bit difficult to deal with, but it's now at release candidate stage and I haven't had the time to revisit it. So this is one to watch and it's out there. It is SOAR and it will contain a bunch of this stuff. I just haven't had a chance to really dig deep into this one, but wanted to put it out there and put it on the map. Finally, Kuku Sandbox. If you are getting malware and you don't have malware analysts and you want to understand what is this malware going to do when it runs, Kuku Sandbox can give you that answer. Not everyone has malware analysts on their team. And even if you do, you probably have so many files you want to analyze that it would make no sense to have them do manual analysis for every single file you get. So Kuku Sandbox can do that for you. It is a bring your own virtual machine. It's a way to basically have a web interface that receives the file you want to analyze. The web interface then turns around, starts up a VM. The VM runs the file, records every single thing that happens, turns it into a report, and then gives that report back to you. It's one of the best ways of telling if malware or if a sample is truly malware outside of your antivirus vendor, because it actually tells you not is it good, is it bad, but what actions does it take? And then it has kind of heuristics that say, hey, this took an action that kind of looks like a virus, but you can also examine all the details. So great supplemental thing to have. The ideal way to use this is to find a way, Zeek and Sorocaba can both do this, for example, to carve out all of the files that are potentially high risk, like PDFs and documents and executables that are going across your network, carve them into a folder, and have everything that hits that folder immediately submitted to Kuku. And this will mean every high risk file that goes across your network will get run through a VM and then will automatically alert you if it looks like malware as a second opinion outside of your antivirus. Great solution for this. Supports a lot of different file types, different operating systems. Does a lot of really good stuff. So there you have it, an enormous tool dump and a complete implementation of security operations with a whole bunch of open source tools, some of which I didn't even have time to talk about. So lots of ways to pick up what's happening on your endpoints, lots of ways to pick up what's happening on your network, save all of it, save metadata about it, do IDS, send all of that information into a SIM, do analytics on it. Those analytics can be written in Sigma. We can take MISP and use that as a source of what to look for the SIM. We can subscribe to threat intel feeds and everything else, have that push to the SIM. All of the alerts that are generated, we can triage through Evebox, Squeal, and the Hive as well, which has its own alert interface. Then we can work our incidents in the Hive in a very easy way using Cortex for automation. We can use NodeRed if we want to create full-on orchestration frameworks. And we can use WalkOff too, hopefully in the near future when that hits a full-on stable release. So with that, the point I want you to take away is you can do a really ridiculously good job with completely free tools. At this point, the quality of your blue team is going to be even more dependent on the people inside of it, right? The people are going to determine how well you can use the tools you have. The tools are now out there, the tools are free, they cover all of these things. So as long as you're aware they exist and have the best thing for the job you need to get done, you can do a great job for absolutely free, plus the hardware, of course, to run these things. So watch all of these tools. They're all being actively developed very rapidly. Versions are changing very quickly, features are being added. So it's never really been a better time to be a blue team. I'm really excited about where all this stuff is going. So with that, if you want any additional info on the class, we got sans.org/sec450 as a reference there. And if you want a podcast release reminder, we have sec450.com/podcast. And with that, I am finished. So if there are any questions, I would be glad to answer them.
Hey, John. Yes, there's quite a few questions, so I'll dive in and get started. Also wondering if we run out of time, is there a way to reach you directly?
Yes, so I'm sure there are going to be a lot of questions. I'm very easy to find online. I'm on Twitter at SecHub, SECHUBB. I'm on LinkedIn. SecHub.com is my website. A whole bunch of ways to reach me, and not hard to find me. So I'd be happy to answer anything offline because I'm sure we'll run out of time here.
All right, sounds good. Also, you can submit something to q@sans.org and I can forward it to John at the very least. Okay, well, we'll start with a couple here. What kind of hardware does Moloch require for a smaller network, about 50 machines? Storage, RAM, CPUs, etc.
So with all of these tools, I won't claim to be the foremost expert in deployment in terms of hardware. For Moloch, if it's a smaller network, it's not going to be really anything outside of what you would. I don't know if you've tried, Security Onion or any of the other things, but obviously the big thing you're going to need there is going to be some CPU for running the Elastic Stack, storing all of the information in the Elastic Stack, and then hard drive space to record it all. Multi-core, 64 gig is generally the recommendation for Elastic Stack, and then SSDs if you want fast retrieval of all that information. Really the size of the hard drives is going to be up to you. Generally what's recommended is RAID 0 for a whole bunch of drives to get as fast as read as possible, because Elastic Stack kind of has its own backup of data. The full PCAP you would probably want to put on a RAID 10 or something like that. But very, very rough, Xeon processor, multi-core, 64 gig at least, I would say, with as much hard drive space as you were willing to sink into recording for that.
All right, well, we got one in, so that's good. But with that, we're out of time. Thank you so much, John, for your great